What are VLANs and why do we care? In this lesson, I'll put this in the description. There's a little bit of theory behind VLANs, but let's just jump to it and describe in a nutshell what this means. By default, all the ports of a switch belong to the same logical network VLAN, VLAN number 1, and this VLAN and the whole infrastructure creates one big broadcast domain. What this means in practice that if, let's say, this computer here is sending ARP request, which is broadcast, the address of the MAC destination is all Fs, it is going to be forwarded everywhere. So every single device in this network is going to receive that broadcast. That can have adverse effect. Let's just say, and I've seen it, some dodgy adapter begins to flood network with some broadcast traffic. It's going to interrupt every single device with this broadcast as they need to process that to decide if the information is directed to them. So that basically broadcast domain needs to be smaller in size. And this is where the VLANs come into place. By the way, this process of flooding is happening also for all unknown MAC addresses or multicast by default unless we address that. So VLAN was introduced as separation, logical separation of broadcast domains. So each VLAN is its own broadcast domain. We can, via configuration, we can configure those VLANs and narrow down the scope of this flooding propagation. So broadcast domain, or VLAN, is going to be a very important aspect of our configuration. But how do we decide how many VLANs, what those VLANs are going to be? Usually it's user work groups or departments. We separate some devices when we need to tighten security, and then we control who accesses that VLAN. Typically voice or video VLANs will be separate from the data VLANs as well. So with VLANs, what they introduced was two types of ports. One is called an access port. An access port is going to be the port that is a member of a single VLAN. The trunk port is the connection that allows multiple VLANs to cross that connection. So typically the ports between switches, so we have in this picture, let's say, red VLAN here at the top and red VLAN at the bottom. Since they form one broadcast domain, they need to be able to communicate. So that trunking port is going to allow that communication for the red VLAN. But since we also have yellow at the top and the bottom and blue at the top and the bottom, that communication between them must be logically allowed. So if there's two or more switches connected together, they're going to form a trunking connection, and the communication between those ports will allow those VLANs. But the question is, how does the port know that it is receiving, let's say, information maybe broadcast from VLAN red, not blue? This is where VLAN tagging comes into play. VLAN tagging is adding and removing on the receiving end a special tag into the Ethernet frame. So this is what the frame looks like. Has a CRC, cyclic redundancy check, there's a data from upper layers, and source destination MAC, preamble, type length, that kind of stuff. When the port is sending, let's say, broadcast, let's go back here, from the red VLAN here, and all red ports will need to receive it, the local switch checks if there's any other ports in the red VLAN. If there aren't any, and it sees the trunk allowing VLAN red, that VLAN red tagging is going to be applied. And this tag will be inserted into the frame and sent across as a tagged frame. That way, the receiving end knows which VLAN it is coming from. Of course, we don't use colors, we use numbers. So this tag is going to have an information about identifier of the VLAN. And that allows the receiving port to know that the port here in the trunk mode receives VLAN red broadcast, not blue. If it receives, let's say, red, determines which ports belong to the same VLAN ID. And if there are some ports that should receive the traffic, the frame is basically forwarded to those ports, but without the tag. They don't need a tag. So access ports don't use tagging, but trunk ports use tagging. And that's how the communication between multiple switches can be accomplished within a particular logical VLAN. In the next video, we're going to tackle this from the practical perspective using configuration and command line interface.